defined by the tendency of an element to undergo a chemical reaction and mix with other elements. So then I gave you some space to brainstorm. What may cause an element to be more reactive than another element? One of those things is low ionization energy. So it means that it is going to easily lose valence electrons. Or, opposite of that, high electronegativity, it's going to easily attract electrons. It's going to easily gain electrons. And then large atomic radius. Oops. We also discussed some families that are more reactive than others. That first family that we said is highly reactive is the alkali metals. They have one valence electron, so they give it up pretty easily. Another family that also has one valence electron is the hydrogen group. Hydrogen will bond with just about anything. And then slightly less reactive than the alkali metals, we have the alkaline earth metals. So those are some of our families. Our non-metal family, the halogens, they only need one valence electron. So they're going to gain that electron pretty easily. So gaining electrons, losing electrons, those are the families that react pretty easily. So based on their position on the periodic table and based on the low ionization energy, high electronegativity, large atomic radius, and the families that we discussed that are more reactive than others, take a look at these 7 elements. Which do you think is going to be the least reactive to the most reactive? So one thing that you can do is, are all of these elements in the same family? When you look at it, 5 out of the 7 are in the same family. 5 of them are in the alkali metals. The other 2, magnesium and calcium, are in the alkaline earth metals. So we said that the alkali metals will be more reactive than the alkaline earth metals. So I want you to take a moment, pause the video, and plot out where you think, make a prediction. Where do you think that these elements are going to fall, going from the least reactive to the most reactive? Least likely to react, most likely to react. Welcome back. We're going to watch a short video that is going to show us the reactivity of the alkali metals.
Whether you've left school or you're still at school, you can appreciate the sheer fun and mayhem that chemistry can be. There's so much to it. Bunsen burners, mixing chemicals. Very nice. Now, you may have been allowed to mix very small amounts of lithium with water. You may, if with a responsible adult, have mixed H2O with sodium. And you may, under very strict scientific control, have witnessed potassium mixed with water. But the odds are, if you have, it will only ever have been on one of those rubbish science videos. There you go, mate, present. Oh, these next 2 are the dog's nuts of the periodic table. They are, if you like, the king and queen of alkali metals. Mix these babies with water, stand well back, and watch the mayhem. And that's just what we're going to do. Mr. Tickle, bring on the rubidium.
Here it is.
Is that it?
Well, it might not look like much, Richard, but it's a highly reactive metal. It's sealed in this glass tube under argon atmosphere conditions, just for safety.
Right, so what's going to happen when you drop that in the water?
Well, imagine, if you will, letting off a hand grenade in a bathtub.
Righto, I'm off. Have that.
Okay.
Good luck. Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody, this one's going to be bad!
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone. Yes!
Wow.
That is more like it. Only on Brainiac do you get that kind of science. But I believe we can go one better. There is one more alkali metal we can legally use.
Yes, Richard, cesium, the emperor of alkali metals, particularly nasty, could go off at any time.
And that's it.
Oh, yes.
Brilliant. I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave you to it. Good luck.
Thank you.
Okay, John. Go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does. Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason, they wouldn't let us have any of that. Still, there you go. Today's lesson. Okay, so that video took a look at the alkali metals and the reactivity of those metals. So they said that last one that they tested was the most reactive, which is on our list, which is cesium. Right before cesium, they tested rubidium. Cesium split the bathtub in half. Rubidium just blew a hole in the side of the bathtub. And then at the beginning of the video, they tested potassium, sodium, and lithium. So potassium is a little bit less reactive than rubidium. Sodium's a little bit less reactive than potassium. And then lithium is a little bit less reactive than sodium. So magnesium and calcium, those are 2 elements that are in the alkaline earth metals. So if we take a look at it, ionization energy is going to be lower for calcium than it is for magnesium. So calcium is going to be our next reactive one, and magnesium is going to be the least reactive. So when we take a look at the reactivity of metal atoms, metals tend to lose electrons. When they lose electrons, they form positive ions to become more stable. So this is easiest for atoms with a low ionization energy. For our metals, the most reactive metal is that element that they said that they weren't even able to test for the video, which is francium. For the reactivity of nonmetals, nonmetals tend to gain electrons. When they gain electrons, they form negative ions to become more stable. So this is going to be easiest for atoms with a high electronegativity. The most reactive nonmetal is fluorine.
You can check the electronegativity with your periodic table, but fluorine has the highest electronegativity. So that's it for today's lesson. You have 3 practice problems to work on for reactivity. Thanks for stopping by. Have a great day.